In this video we will be looking at the solution of the assignment problem that I gave you yesterday. So in this problem you were actually asked to calculate terms like coefficient of compressibility, compression index and coefficient of volume change, and at the end you were also asked to calculate the settlement of the soil mass. Now the question says that the void ratio gets decreased from 1.068 to 0.944 when the pressure is increased from 60 kilonewton per meter square to 120 kilonewton per meter square. So what I have done, I have assumed the initial void ratio to be E1, which is 1.068, and it has decreased to a void ratio of E2, which is 0.944. That means E2 is the final void ratio. Similarly, the initial stress was 60 kilonewton per meter square, which I have denoted by sigma 1 dash, and it has increased to a stress of 120 kilonewton per meter square, which is denoted by sigma 2 dash. And mind you, sigma 2 dash is the final effective stress. Now this problem can actually be solved by two approaches. Okay, let us look at the first approach. Here we calculate the coefficient of compressibility, which is denoted by AV. Now we know that AV is actually the slope of the curve plotted between void ratio and effective stress. So this is the curve, and if I want to calculate the slope of this curve, the slope of the curve gives me coefficient of compressibility. Now how do I calculate the slope? It is change in void ratio divided by change in effective stress. Okay, and I have also put a negative sign over here, which shows that the slope is decreasing or in the downward direction. In the next step, what I do, I expand the change in void ratio. So change in void ratio is final void ratio minus initial void ratio. Similarly, change in effective stress is final effective stress minus initial effective stress. Now what is E2? E2 is 0.944 and E1 is 1.068. Sigma 2 dash was 120 and sigma 1 dash was 60. Now you will find that 0.944 minus 1.068 will give you a negative value, but there is a negative sign already outside the term, right? So this negative sign will actually make the entire value positive, and as a result you will get the answer as 2.066 into 10 to the power minus 3. Okay, now regarding the unit, you see AV is change in void ratio divided by change in effective stress. So we know that void ratio has got no unit. It is the only unit of effective stress that we need to take care, right? So effective stress unit is kilonewton per meter square. So since it is at the denominator, meter square will go to the top, and as a result the overall unit that I will be getting is meter square by kilonewton. I hope you understand this. Okay, so this is the value of coefficient of compressibility or AV. Similarly, if I am to calculate compression index, so we know that compression index is the slope of the curve plotted between void ratio and effective stress, where effective stress is taken in a logarithmic scale. Now if you look at this curve, it is also sloping downwards. So in the expression of compression index, I have put a negative sign which shows that the slope is acting downwards. So in this case also you will find that the change in void ratio will come out to be negative, but because of the negative sign present outside, the overall value will be positive. Now compression index is a unitless term. The answer is 0.411, and there is no unit because you see void ratio, we know it has got no unit. At the denominator we have got sigma 2 dash by sigma 1 dash. So the unit of sigma 2 dash is kilonewton per meter square, and again the unit of sigma 1 dash is kilonewton per meter square. So both of them cancel out each other, and as a result of which there is no unit in compression index. So next is coefficient of volume change. It's quite easy to calculate. I know the value of AV, I have just calculated, and I need to know the initial void ratio. So initial void ratio in my case was 1.068. So the result turns out to be 9.99 into 10 to the power minus 4 into, the unit is meter square by kilonewton. Okay, now if I am to calculate the settlement of the soil mass, it can be calculated many ways. here I have calculated the settlement using the coefficient of volume change. Okay, so settlement I have denoted by SC. SC means the primary settlement. Okay, MV value, this is the value of MV. H naught is actually the initial height, so initial height as per the question is 8, and change in effective stress, so I know change in effective stress is 120 minus 60, which will give you a value of 60 kilonewton per meter square. So this is the value of settlement occurring in the soil. Okay, now settlement of the soil can also be calculated by using this basic equation. Now here if you calculate the settlement, ultimately you will find that the value turns out to be negative. So is my answer wrong? Definitely not. Here the negative sign says that the settlement of the soil is occurring in the downward direction. Okay, negative sign is signifying the downward settlement of the soil. So finally, once you get the negative sign, you do not need to be afraid. You can write that the settlement occurred is 0.479 meter, and the negative sign justifies that the settlement is occurring in the downward direction. Okay, now let us look at the second approach. This is the approach adopted by most of the textbook. Now you will find that this approach is quite similar to the first one, but there is a minute difference. Alright, now before diving into the solution, let me tell you a very basic thing. Suppose this is a figure given to me and I ask you to calculate the slope of this line. Okay, so what you will say, the slope of this line is y by x, right? This is a very simple mathematical operation. Now if I want to calculate, say, coefficient of compressibility, I am not concerned with the nature of the slope of the curve. I do not want to know whether it's sloping upwards or it is sloping downwards. I simply want to calculate the slope. So if I want to calculate the slope, it will be y by x. That means on the y I have got void ratio. So what is the change in void ratio? It will be 1.068 minus 0.944, right? This is the value of y. So that is what I have written, 1.068 minus 0.944. And what is the value of x? X will be this much. This is 120 minus 60, right? So if I solve this, I will be getting the value of AB, which is 2.066 into 10 to the power minus 3. So the answer is exactly same to the one which we got in the first approach. Similarly, if we look at compression index, it will be simply the slope of the curve. I am not concerned with the nature of the curve. Okay, so I do not put a negative sign over here. So if I want to know del E will be this distance, right? Del E means it is y, so it will be this distance. So this distance is 1.068 minus 0.944. And what is the value of x? X will be this distance. It will be log 120 minus log 60. So log 120 minus log 60 can be written as log 120 by 60. So if you again solve it, you will be finding the answer to be 0.411, which is exactly similar to the one in the first approach, right? Now see, the main intention of me making this video is, most of you were actually doing a peculiar mistake when calculating AV. Okay, you see, you write that coefficient of compressibility, or AV, is minus delta E by del sigma dash. Okay, but immediately in the second step there is no negative sign. Okay, you simply write it is initial void ratio minus final void ratio. So if you are considering the minus sign, simply put the minus sign over here, and you need to write 0.944 minus 1.068. That means if you are using the minus sign, you need to use the first approach. And if you do not want to use the minus sign, do not put it over here. Okay, if you do not put the minus sign, it becomes the second approach. In that case, this would have been correct. Moreover, the unit here is also wrong. It should be meter square by kilonewton. So I hope you have realized the mistakes which you have done, and you will take care of it in the future. Okay, so that's all for today now. Thank you.